Hey everybody, welcome to the 6.5 notes titled Rhombi and Squares. Rhombi is plural for rhombus, and at the top of the notes I'm going to go over the definition of a rhombus. So a rhombus is a parallelogram with all four sides congruent. So normally when we think of four sides congruent, we think of a square, and a square is actually a special type of a rhombus, but you can have four sides being the same thing and not be a square. A rhombus has all properties of a parallelogram and two additional characteristics listed below. So these last two are unique to a rhombus, but these first four are the same as a parallelogram. A parallelogram and a rhombus have opposite sides that are parallel and congruent. And so if you have all four sides the same, then yeah, that makes sense. Your opposite angles would be congruent. So like angle G would be congruent to angle J, and angle F would be congruent to angle H there. And your consecutive angles would be supplementary. So if you were to add together F and G, it would equal 180. Next, it says your diagonals bisect each other. So what that means is if you draw your diagonals where they intersect, it's creating, congruent segments there, and then it's creating other congruent segments right here. And then these last ones are unique to rhombi. Diagonals are perpendicular to one another, and diagonals bisect a pair of opposite angles. So when it says they're perpendicular to one another, it's telling you that it's making right angles. So basically all these angles here are right angles, creating four right triangles here. And then when it says it bisects a pair of opposite angles, what it's saying is it would cut in half this large angle of GFJ. So it would bisect that angle, creating, bisect means it cuts it in half. And then same thing for the diagonal going from G to J, it would bisect those angles and cut those in half. So now let's talk about a square. A square is a parallelogram with four congruent sides and four right angles. Recall that a parallelogram with four right angles is a rectangle, and a parallelogram with four congruent sides is a rhombus. Therefore, a parallelogram that is both a rectangle and a rhombus is also a square. So next I wrote, all the properties of parallelograms, rectangles, and rhombi apply to squares. A square is also a rectangle because it's a parallelogram with four right angles. A square is also a rhombus because it's a parallelogram with four congruent sides. Diagonals of a rhombus aren't congruent to each other unless it's a square. So that last one about diagonals, the diagonals of a rectangle would be congruent to one another, and the diagonals of a square would be congruent to one another, but diagonals of rhombi are not congruent to one another unless, of course, that rhombus is a square. So for my first example here, I have this picture and it says 24 inches all around. The text says, given the shelf measurements in the diagram, can you assume that the shelf is a square? Oh, by the way, skip this. You're building a case with glass shelves for collectibles. So I wrote that you can't assume that it's a square because you don't know if all the angles inside are 90 degrees, and you don't know if the diagonals are congruent. If you knew one of those two things, then that would be enough to assume that this is a square. So yeah, your first instinct might be to say, oh, it looks like a square, therefore it must be a square. But remember, in geometry, never assume anything's true unless it is given to you. So what can we conclude about this? We can conclude that it is a rhombus because all four sides are the same, but we don't know anything else about it. So therefore, all we know right now is that it's a rhombus, and the jury's still out on whether or not it is a square. Now, if they come back and say, you measured the diagonals and find they're both 33.94 inches, then that means the diagonals are also congruent. So since you know that all four sides were congruent and the diagonals were congruent, then yes, now you know it's a square. So for my second example here, we're trying to determine with the information that's given in this photo, is this a rectangle, rhombus, or a square? So because I'm given two pairs of congruent angles, the opposite angles are congruent, I can conclude that it's not going to be a square and not going to be a rectangle because all four of those angles are congruent. They're right angles. So therefore, the best thing I can say is that this must be a rhombus. So in this next example, I'm given that this is a rhombus, and it says FJH is 82 degrees. So this angle right here is 82 degrees. And with that information, we're trying to figure out what angle KHJ is. So for starters, since we know this is a rhombus, we know that the diagonals bisect one another. So that's the right angle symbol. It's kind of ugly, but we know that there's a 90-degree angle there. And then we also know that the diagonals will bisect the opposite angles. So if this is 82 degrees at the bottom FJH, then this is 41 degrees right there. And so if I have 41 degrees and I have 90 degrees in my triangle, talking about this triangle right here, then all you have to do is take those away from 180 because all the angles in a triangle add up to 180, and you get 49 degrees for the measure of angle JHK. In this example, same picture, GH equals x plus 9 and JH equals 5x minus 2. Well, by definition, a rhombus, all four sides are congruent. So just take those two expressions and set them equal to each other to solve for x. So of course, when solving for x, we got to get our x's to one side. So I'm going to minus my x to the right side. So 5x minus x is 4x. And so I got to get my constants to the other side. So if I got my x's on the right side, I got to get my constants to the left. And so I'm going to add 2 over, and 9 plus 2 is 11. I get 11 equals 4x. So divide both sides by 4, and you get x equal to 11 over 4. And so if I ever ask a follow-up question like, what does JH equal or GH equal? Well, all you would have to do is plug those into either one, and you get the same exact answer because you just set them equal to each other. So since JH was just x plus 9, I just plugged in 11 over 4. If you were to convert that to least common denominator, then the 9, that would be 36 over 4. So that's going to give me an answer of 47 over 4. And of course, you're welcome to type that into a calculator and approximate it if you wish. So in example 4 here, I'm given another rhombus. And it says if measure of angle WZX is equal to 39.5 degrees, find measure of angle ZYX. So WZX would be this little angle right here, and then ZYX would be the larger angle, okay? And so since this is a rhombus, we know that the diagonals bisect the opposite angles. So if they bisect them, then that means this is also 39.5 degrees. And it's not super important, but that would also mean that these angles up here would be 39.5 degrees. Now, how does that help us with this one? Well, remember, they also intersect at perpendicular angles, so that means it is a right angle right there. And so all we really need to do is just take 90 and 39.5 away from 180, and we'll figure out this angle here, and then all we need to do is double it to figure out what ZYX is. So taking away 90 and 39.5 from 180 gives me 50.5 degrees, so we got to double that. Doubling that gets you 101 degrees for your final answer. So for letter B, same picture. It says if Wx equals 8x minus 5 and Wz equals 6x plus 3, find x. Same thing as the earlier example. If you're given two sides, it doesn't matter which two sides, they're all four congruent. So let's set these equal to each other and solve. So we got to get our x's to one side, so it makes the most sense to minus 6x under the 8x. And so if I get my x's over to the left-hand side, I'm going to need to get my constants over to the right-hand side. So I'm going to add 5 over to the 3. And so I get 2x equal to 8. And so if you divide 2 to both sides, you'll get x equal to 4. And so if I ever ask you what does wz or wx equal, it doesn't matter which one you plug it into because wx equals wz. So I'll just plug it into wz. 6 times 4 plus 3 would be 24 plus 3. So that's 27.
In example C, it says if zy is 65 and zv is 56, find vy. So zy is right here. It is opposite of this right angle, making zy a hypotenuse. And so zv is a leg of this same triangle, and vy is also a leg of that triangle. So we got 3 legs of a right triangle. We know 2 out of the 3 legs. That means we're going to have to use the Pythagorean theorem. So I went ahead and I redrew that triangle, and so just to reiterate, 65 is my hypotenuse. So when you do the Pythagorean theorem, it's a squared plus b squared equals c squared. I'm going to use 65 for my c squared. It doesn't really matter which one is a or b with these 2 legs. All that matters is that we get our hypotenuse correct. And we know 65 is our hypotenuse because it's opposite of that right angle. So here I have it set up, 56 squared plus x squared equals 65 squared. So squaring both of them would produce 3,136 plus x squared equals 4,225 minus 3,136 to the other side, and 4,225 minus 3,136 is 1,089. And so you got to just bring down the x squared. And so to get rid of the power of 2, all you need to do is square root both sides. And the square root of 1089 is 33. So x equals 33, and that's what vy equals. You just say vy equals 33. And yeah, that's pretty much it on that one. Moving on to example 5 now, it says the diagonals of a square MNPQ intersect at point A. And so we're going to use that information to solve this problem right here. If measure of angle AQP is 7x minus 4, find x. So let's go back and look at the picture. AQP is going to be this angle right there. So to solve this problem, we need to be able to set this equal to something. So let's see if we can figure out what the angles of this square are. So you know, these diagonals cut the square into 4 separate triangles. And remember, a square is also a rhombus, so all these diagonals intersect at right angles. And so you have a 90-degree angle there. And we also know that the diagonals will bisect their opposite angles. And so a square has a 90-degree angle here, 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 right? It has a 90-degree angle for all 4 of its angles. So if you're bisecting it, then you're creating a bunch of 45-degree angles. So I'm going to write 45 degrees here and here. And so now we figured out what angle AQP is. It's a 45-degree angle. So I'm just going to set that expression equal to 45 and solve for x. So here I have 7x minus 4 equal to 45. I can add 4 to the other side, and I get 49 equal to 7x. And we know that we have to divide both sides by 7, and so 49 divided by 7 is going to be 7. So yeah, x equals 7. That's it. On example B, it says if NA equals 5, find PA and NP. So if NA is 5, I can stick a 5 right here. Find PA and NP. So let's just redraw this triangle right here. Okay, so we know there's a right angle at the bottom of the triangle there where angle A is, and we also know that the other angles inside the triangle are both 45-degree angles. And so that makes this a 45, 45, 90 triangle. So if you think back to the 8.3 notes on special right triangles, we talked about 45, 45, 90 triangles there. And so it says that both the sides across from 45-degree angles are the same thing. And so if NA is 5, then AP or PA is also 5. And then the hypotenuse is that same number, just with a square root of 2 attached to it. So now we figured out what PA and NP are. So that's going to draw these notes to a close. Thank you for watching, and goodbye.